My name is Steve Disher. I'm with ISP Supplies, and I want to welcome you to today's webinar where we're going to take a quick look at MikroTik Router OS and its firewall facility that's built into Router OS. So today's webinar is going to be just a short look at the type of material that we cover in our MikroTik certification courses. So if you would, take a moment and silence your phones and follow along with us. And hopefully there'll be some information here that will be helpful to you as you begin using the MikroTik products. So first of all, what is the purpose of a firewall? And firewalls have multiple purposes, but the first and probably most important purpose is to protect the router itself. And then secondary to that is that firewalls provide the ability to protect your clients from unauthorized access. And the way this is done is through a variety of means, but primarily it's done in the Firewall Filter facility. In the Firewall Filter facility, rules are created that are what we call packet matchers. That is, the rule defines some attributes about packets that are entering or passing through the firewall. And if the packet matches, then it performs some kind of an action on that packet. If you're looking for firewalls in Router OS, you're going to find it in Winbox, and Winbox is the configuration GUI that we typically use, especially in our courses, and also in real life as well, but it's found under IP and Firewall. So if you're in Router OS in the Winbox facility, it's under IP and Firewall, and there's a tab that will open up in that window called Filter Rules. Now, in this particular example, you'll notice our filter rule list is completely empty. And that is what you're going to see if you have reset the router to the default configuration without a default config. Now, that sounds kind of like a misnomer, an oxymoron, but when you reset a router, you have the choice of either being able to go back with a factory configuration, which has some basic firewall rules, or a factory configuration that has no config at all. And that's a subject for another time on how you achieve those options, but they are documented really well. So in this case, we have reset the router and we do not have a factory configuration installed. So we have a blank slate to start with. In order to create a new firewall filter rule, we simply click this plus sign, and that will help us to create a new firewall filter rule. So let's talk about these rules for a moment. We said prior that the rules are packet matchers, and so because of that, they work on an if-then principle. So if a rule matches a packet, then an action is performed on that packet. The rules are ordered in what we call chains, and chains are something that we'll cover for you in just a moment. And there are predefined chains and user-created chains. For purposes of today's webinar, we are only going to look at the predefined chains. Chains are somewhat confusing at first, but it's simply a place in the router, a place in the flow where we are going to look at packets. Two tabs within a new firewall rule are really required to make a rule that does anything. And the first is the General tab, which is the tab on the far left. In this tab, we are going to define where we are going to look at packets, which flow we're going to look at. Another way to say that is which chain we're going to look at. This particular rule uses the input chain. The input chain is going to match all packets that are going into the router. More on that in a moment. And then we can define other criteria within this rule to match other portions of the packet header, such as source address. That would be what address the packet was originated from, what device crafted that packet. Destination address would be which address the packet is going to, and so on. We can also match on protocol, which interface the packet enters, and a host of other options. On the Action tab is where we are going to determine what action we perform on the packet. And for today's webinar, the two basic actions we're going to look at are accept and drop. And so accept means we're going to allow the packet to pass, and drop means we're going to drop the packet. So a while ago we talked about filter chains. And so now I think it's an appropriate place to talk about what are these chains, what do they mean, and so we'll do that now. Chains are what I like to say a strange way to say places we can look at and act on traffic, and there are 3 default or built-in chains in RouterOS. The first one you see here in blue is the input chain. The second we'll look at is the forward chain, and the last is the output chain. Now, by far, input and forward are the 2 you're going to spend the most time writing rules around. The output chain is for some more advanced functions. You can build a great firewall to protect your router and use only the input chain, and your router will be fully protected. If you're writing rules to protect your clients on your network, then you would put those rules in the forward chain. But again, we're going to start with the input chain, and we're going to kind of dwell on that today. A little bit of summarization about what we talked about before. That is that when we are creating firewall rules, they can be placed in one of 3 default chains. The input chain, which is all packets that are going to the router. The output chain, that is packets coming from the router, and we won't do much with the output chain. And the forward chain, that is for packets that are going through the router. This is what we call an IP firewall flow diagram, and this is the best way to describe what's happening in the router and this concept of chains. So let's start right here down the lower left-hand corner with input interface. Input interface simply means an interface like an Ethernet or a wireless interface where a packet is entering the router's flow. The very first place that it goes is something called contract or connection tracking. This is the built-in facility that allows us to determine where packets are coming from, where they're going, and to keep track of those things. And we cover this in depth in our MikroTik MTCNA courses. The next is the destination chain, or the DST NAT chain. This is the chain where we can make changes to the destination address of the packet. Again, this is covered in depth. But what I want to focus on is this last one, the routing decision. So when a packet enters an input interface, the very first decision that's made about it is a routing decision. And simply what that decision looks at is the address local. That is the destination address of the packet an address that's configured on this router? And if the answer is no, then it's going to go through the forward filter and then finally pass out of the router and go to the destination, which is probably a client on your network or maybe something out on the internet. The other routing decision that could be made is a yes decision. The address is a local address. In that case, it's going to hit the input filter. So in today's webinar, we're going to focus on the input filter, and that is rules that are going to protect the router itself from any type of attack or even from someone who's trying to manage the router who is not on a network that we consider to be a secure network. So what are some sources or actually some uses for the input chain? Well, first of all, the built-in HTTP or web server on the router. In case you don't know, and I suspect you probably do, but RouterOS can be configured using a web browser, using the HTTP or HTTPS protocol. So there's a built-in server on the device that is able to populate your web browser and to allow you to configure the router with a web interface. And that is the HTTP server. So that is one of the things that lives within this local process. So for example, any packets with a destination address that is a address on the router will go to the filter input, and then they will finally be handled by the internal HTTP server. Another example is the Winbox server, the thing that is handling your Winbox request that you're sending to the router, and also the built-in DNS caching facility that is in RouterOS. So all of these things are going to be passing through this filter input or input filter. Looking down at our diagram here at the bottom of the screen, the input filter is all packets going into the router, and those are represented by this blue block right here. Now, one misnomer I want to kind of reinforce here is that one of the mistakes that I see people make is believing that the packet flow is something like this. A packet goes in the input filter, through the forward filter, and out the output filter, and that simply does not happen. A packet will only hit, by default, one of these filter chains and not the others. There are ways that we could manipulate the packets and make them do abnormal things, but for purposes of our discussion today, let's assume that a packet will only hit one of these chains. So if we are trying to manage our router using our web browser, all of those packets will hit the input filter. So now I have switched over to my screen showing the Winbox utility that we use to manage RouterOS devices. And Winbox is really intuitive after you get used to using it a little bit. But the facilities we're going to look at today are under IP, Firewall, and Filter rules. And you notice this router has been reset to the factory defaults with no default configuration. So we have a blank slate that we're going to start with. Now there's some other tabs here: NAT, Mangle, RAW, service ports, connection, address list, layer 7. All of these things are facilities that allow additional functionality and additional complexity to RouterOS rules. We are only going to look at the filter rules today. So the first thing we'll do is we'll click the plus sign and we'll create a new firewall filter rule. And let's look at some of the things that have to be configured to make this work. First of all, we talked about chains. We have 3 built-in chains: forward, input, and output. We are going to look at the input chain first. And if you remember from a few moments ago, these are packets that are going into the router. And since the rules work on an if-then principle, the first rule that matches a packet is the one that we are going to act on. And we can't just simply write rules that disrupt traffic. We have to write rules that enable traffic as well, and those have to be higher up in our list. Otherwise, they will not ever get seen by the different packets. So we'll start with an input rule. In this case, our laptop has an IP address of 10.0.25.0/24. Now this is CIDR notation if you're not familiar with it, but basically this address represents all addresses from 10.0.25.0 through 10.0.25.255. And so that would include my laptop, which is in that range of 10.0.25.1 through 10.0.25.254. So any packets coming from my laptop will match this rule, regardless of protocol, port, interface, and so on. The next thing I need to set to make this a workable rule is the action tab. And here I'm going to accept the default action of accept. So what does this rule do? On the input chain, if a packet comes from any computer within this Class C subnet, I'm going to accept that packet. And I'm going to use the comment feature here just to remind me what this rule does. And I just put accept from my network, and I'll click OK. And there you see that particular note. Now, the next thing I'm going to do is to write a rule that drops traffic from everywhere else. And this can be really dangerous because once we start dropping traffic, if we haven't written our rules correctly, we may drop our own traffic. So we're going to use this button in the upper left-hand corner called Safe Mode. What Safe Mode does is it allows us an escape route. If we write a rule that disconnects us from the router, everything that has been changed since we went into Safe Mode is going to be dropped. So, in order to have a complete firewall, we have to actually disrupt some kind of traffic. So I'll click the plus sign. I'll go back to the input chain. And now this rule is going to match everything in the world, because if you don't populate these boxes, then they match everything. Another thing you have to be careful of here, sometimes people will click in a box and then they'll forget that they clicked in it and they'll move on. Well, if I hit apply right now, it's looking for some values that I may not have intended. So I'll go ahead and shut any boxes that I want to be wildcards or to match everything. Another little gotcha is this little checkbox here, which is not a checkbox, it is a not box. And if we really zoomed in on it, what we would see is that is an exclamation point. So that is not a checkbox or tick box, that is an exclamation point. So this rule matches everything. So on my action tab now, I'm going to say drop, and I'll add a comment, drop everything else. So I have two rules. The first one matches only packets coming from my laptop. The second rule drops everything else. And so in this case, if I were to start a ping to this router from an address that is not within this 10.0.20.0/24 subnet, those packets would be dropped. Okay, so pretty straightforward. So how can we take this concept now and extend it into a set of rules that would be usable to protect our router? And so I'll show you that now. I'm going to first of all get rid of the drop rule, and I'll go back to my accept rule. In this case, I'm going to change the source address to something a little more common, like 192.168.1.0/24. That's a typical RFC 1918 or private address. It's used by a lot of networks, and we'll just leave that as accept. So that will allow anything from my local area network. The next thing I'm going to do is to use a more advanced feature that's built into RouterOS, and that is something called connection states. So we get into great depth on this in all of our MikroTik classes, but let it suffice to say that we want to allow established connections and we want to allow related connections, and we're going to allow those on the input chain, and the action will be accept. And the comment is allow established and related connections. And I'll click OK there. Now, it probably is a good time now to talk about interfaces. So this is a CRS 326-24, which has quite a few interfaces on it. And so typically we have a bridge interface, which would contain all of our local area network devices, our LAN devices. So I'm just going to change the name of this interface a little bit and call it bridge-LAN, so it makes a little more sense. And understand that I am connected to a port that is on the bridge-LAN interface. And again, we go into great depth on all these subjects in our RouterOS classes. So the next rule we're going to write is going to be based on that interface. And we're going to say if it comes in the interface bridge-LAN, and if the connection state is a new connection, then we will accept that connection. And I'll say accept new cons from the LAN interface. And if you notice, I did not change the chain there, so I'll go back and change that to the input chain. All right, so let's go back and look at the rules that we have. The first one is going to accept management traffic if it comes from a source address on this particular subnet. The second one is going to allow established and related connections. Now, this is important for the router to be able to ping other devices on the internet. And again, we go into a lot of depth in this in our courses and why that is. But for purposes of today's webinar, just accept that that's what we need to do. And then finally, we're going to allow new connections to the router, but only if they come from what I consider to be a secure interface, which is our bridge interface. So now you can probably guess that we have allowed everything that we would consider to be acceptable traffic. So we need one more rule on the input interface, or sorry, on the input chain. And that is going to be our drop rule. And I'll comment that as drop everything else. So as long as this rule is at the very end, we're going to allow the things that matter, and we're going to drop everything else. So at this point, this firewall will accomplish everything that you really need to accomplish to be able to protect your router. Will the router be able to ping out from itself and then receive replies of those pings? And yes, it will be able to because of this rule. This rule says allow established and related connections. Will devices on our local area network interface on, let's say, the 10.0.0.0/8 subnet, will they be able to get to this router and to manage it? Yes, they will, because they are connected to our bridge, which says allow new connections if they come in the bridge interface. But now the inverse of that is not true. If a new connection comes from outside our network, let's say from the internet, that will not be matched by this rule. Instead, it will be matched by this drop rule. So that's a very quick introduction to several things. First of all, how MikroTik Router OS is able to act on packets in the input or the forward or the output chain. Secondly, what each of those chains does. And then finally, how we can write some simple rules that will protect our router. So we're about out of time for today. We've been going about 20 minutes on today's webinar. I hope you found some tidbits in here that could be helpful to you. We will go into at least 3 days of intense training in our MikroTik MTCNA courses, during which time we will look at each of these subjects in great detail. And hopefully you'll be able to join us for one of those live courses here at our office in College Station, Texas. And until then, we appreciate your attendance today and hope you have a great day.